In this video, we're going to talk about the rank of a matrix, right? Rank of a matrix. We'll talk about the rank of a square matrix and of a non-square matrix. And here, I'll be using a particular method to show you how to determine the rank of a matrix. There are actually different methods of determining rank of a matrix, but I'll be showing you how to determine the rank of a matrix by converting the matrix into row echelon form, right? Row echelon form. Let's start with the 2 by 2 matrix. I have the matrix A with the entries 1, 2, 3, 4. We have to determine the rank of this matrix A. Now, the row echelon form is actually in this format. Let's say I have 1, 2, 3, for example, 0, 6, 5, 0, 0, 8. This is actually the row echelon form. All elements below the principal diagonal are 0, 0, 0, 0. So for a 2 by 2 matrix, this is for a 3 by 3 matrix. For a 2 by 2 matrix, 1, let's say 2, 0, 5. This is the principal diagonal. The element below it is 0, right? We are trying to convert this matrix A into a matrix of this form, an upper triangular matrix. This is actually an upper triangular matrix, a matrix in which all elements below the principal diagonal are 0. So the goal is to convert this matrix A into this form and then determine the number of non-zero rows. Okay, let's perform some elementary row operations to achieve this. This is the matrix A, 1, 2, 3, 4. Okay, I want to change this number to 0. Okay, that's the first thing, to change this number here to 0. See how I'm going to do it. This is row 1, this is row 2. Okay, row 1, row 2. It means that in the new matrix, this element here will be 0. This first row will remain, but this second row will be modified. If I multiply this element here by 3 and subtract 3 from it, I will get 0. So let me say row 2, the new row 2 is obtained by saying row 2 minus 3 row 1. Yes, if I multiply this row 1 by 3, 3 minus 3 is 0. So I'll put my 0 here. Multiply this by 3, that will be 6. 4 minus 6, 4 minus 6 is minus 2. That's it. I can write the matrix as like this. 1, 2, 0, 2. It's simple because if I divide row 2, okay, let me write it. Row 2 divided by minus 1. Or I can even divide it by minus 2. I will get this matrix. You get the point? So I've converted this matrix now into the row echelon form, and this is what we have. Is there any row here in which all the entries are 0? No, there is none. So I will say that the rank of this matrix is equal to 2. How is it 2? It is 2 because none of the rows have all the elements as 0. That's the reason. What if I want to determine the rank of the matrix? Let's say the matrix A with the entries 1, 2, 2, 4. Looking at this matrix, I can say that the rank of the matrix is going to be 1 because I can see that one of the row is a multiple of the other. If I multiply row 1 by 2, I will get row 2. 2 times 1 is 2, 2 times 2 is 4. So that tells me that the rank is 1. But let's perform the elementary row operation and convert this matrix into a row echelon form. See, row 1 will remain, but I need this row 2, I need this particular element here to be 0. Okay, you get the point. We are following this pattern. This to be 0. Multiply row 1 by 2, subtract row 2 from that result, write it in the new row 2. or multiply row 1 by 2, okay, subtract that result from row 2. I will still write it here. It's the same. So let's say the new row 2 is, let's say 2 row 1 minus row 2. Multiply this by 2, subtract this one from it. 2 times 1 is 2, 2 minus 2 is 0. It's 0 now. Let's see what happens here. 2 times 2 is 4. Now we are multiplying row 1 by 2. 2 times 2 is 4. 4 minus 4 is 0. Can you see that in this resulting matrix, one of the rows have its elements as 0. All the elements in that particular row, 0. That's the second row here. So for the rank of the matrix, we are looking for the maximum number of non-zero rows. Non-zero rows. That's what we are looking for. This row 2 has all the elements 0, so we don't need it. It is only row 1, only one of the rows, which is row 1, that has non-zero rows. It means that the rank of the matrix is equal to 1. That's it. Alright, let us consider the rank of a 3 by 3 matrix. Okay, the rank of a 3 by 3 matrix. Let's look at the matrix B that has the entries 5, minus 1, 0, 3, 1, 2, 2, 3, 6. What is the rank of this matrix? We are still going to convert this matrix into the row echelon form like this. Alright, so to perform some elementary row operations, the first thing here is to change this element here to 0. I want to work with row 2 and row 3. See, if I multiply this 3 by 2, what will I get? 6. If I multiply this 2 by 3, I will get 6. 6 minus 6 is 0. 6 minus 6 is 0. So I will just simply say the new row 2 will be multiply row 3 by 3, 2 times row 2. See, times this by 3 is 6. Times this by 2, that's 6. 6 minus 6 is 0. Times this by 3, that's 9. Times this by 2, we are timesing the entire row 2 by 2 and the entire row 3 by 3. 3 times 3 is 9. 2 times 1 is 2. 9 minus 2 is 7. Times this by 2, that's 4. Times 3, that's 18. 18 minus 4 is 14. You get the point? So all other rows remain. 5 minus 1, 0. 2, 3, 6. I can easily simplify, or let me reduce this matrix by dividing the entire row 2 by 7. 0, 7, 14, they are divisible by 7. So if I divide I will get this matrix 5 minus 1, 0, 0, 1, 2. Because 0 divided by 7 is 0, 7 divided by 7 is 1, 14 divided by 7 is 2, and 2, 3, 6. You get the point now? So I've made this one to be 0. The next thing is to make this one 0. So to make this one 0, see what I'm going to do now. I cannot work with row 2. I'm going to work with row 1 and row 3. If I multiply this by 2, that will be 10. Multiply this by 5, that will be 10. 10 minus 10 is 0. So I'm just going to say the new row 3 is obtained by performing the operation 5 row 3 minus 2 row 1. See what I will get. Row 2 will remain 0, 1, 2. Of course, row 1 will remain 5 minus 1, 0. But row 3 will change. See, multiply this by 2, that's 10. Multiply this by 5, that's 10. 10 minus 10 is 0. Multiply this by 5, that's 15. Remember, 15. Okay. Multiply this by 2, that's minus 2. So we are seeing 15 minus 2. And what's that? 17. Okay, multiply this by 2, that will be 0. Multiply this by 5, that will be 30. So 30 minus 0 is 30. Good. So we have succeeded in making these two entries 0. Let's make this one 0 now and see. I can't work with row 1 and row 3. I can only work with row 2 and row 3 to achieve that result. So if I multiply this by 17, 17 minus 17 is 0, right? So I'll just simply say the new row 3 is obtained by saying 17 row 2 minus row 3. You get it? Multiply row 2 by 17, subtract row 3 from the result. So I'll be having the matrix. The first row will remain the same. In the second row, I'll be having, okay, multiply this by anything to get 0. Same thing here to get 0. So here will be 0, here will be 0. 17 times 1 is 17, minus 17 is 0. 17 times 2, that's 34. 34 minus 30 is 4. This will still be 1, this will still be 2. So we have succeeded in transforming the matrix into a row echelon form. You can see that this is the principal diagonal. All entries below the principal diagonal are 0. Now check. In this resulting matrix, there is no row that has all 8 elements as 0. Are you seeing it? There is no situation like all of the elements here are 0, all of them here are 0. Some of the rows have 0 elements, but not all elements in that particular row is 0. And for that reason, the maximum number of non-zero rows is 3. Okay, so I can say that the rank of this matrix is equal to 3. Take note, I can write rank as, let's say I have B now, I can say the rank of the matrix is, and that's 3. Row, this is a row, the Greek sign, ROHO. Okay, look at this matrix. This is a 3 by 3 matrix also. Let's determine the rank of the matrix K with the entries 3, 4, 5, 1, 2, 3, 4, 5, 6. Okay. Performing some row operations, let's see what the rank of the matrix is. First of all, we have to turn these elements to 0. So whatever operations we are going to perform now will affect row 2. So the entries in row 1 will remain. The entries in row 3 will also remain. But the entries in row 2 will change. Look at it. Let's make this 0. If I multiply this entry here by 3, okay, if I multiply this one by 3 and I say 3 minus 3, that will be 0. So let me see. The new row 2 is obtained by saying row 1 minus 3 times row 2. 4 minus 6, that will be minus 2 because 2 times 3 is 6. 5 minus 9 because 3 times 3 is 9. 5 minus 9 is minus 4. If I divide this row 2, I say the new row 2 should be row 2, the old row 2, which is this one, divided by minus 2. I will get this matrix 3, 4, 5, 4, 5, 6, 0, 1, 2. Yes, because divide this by minus 2 to get 0, by minus 2 to get 1, by minus 2 to get 2. So the next target is to change this one to 0. Okay, so that's what I'm going to do. I can't work with row 2 because of this 0. I can only work with row 3 and row 1 to make sure that this one is 0. So if I multiply this by 4, Here will be 12. Multiply this by 3 to be 12. 12 minus 12 is 0. So I will say multiply row 1 by 12. That's row 1 by 4 minus multiply row 3 by 3. And this will give me the new row 3. You get the point now? So 4 row 1 minus 3 row 3. 4 times 1 is 12. This is 4 times 3, 12. 3 times 4, 12. That will be 0. Minus it. Multiply this by 4, 16. Multiply this by 3, 15. 16 minus 15 is 1. Multiply this by 4, 20. By 3, 18. 20 minus 18 is 2. So here's this 0, 1, 2. Here's 3, 4, 5. And you see what's happening here? That some rows are exactly the same. You can see. So that tells me that the rank is 2. See, I want to make this one 0. So I can easily work with row 1 and row 2. The old row 1 will remain the same. The old row 2 will also remain the same. But this old row 3 will change to something. Okay, to make this one 0, okay, I can easily say the new row 3 will be obtained by subtracting row 3 from row 2. Row 3 from row 2. 0 minus 0 is 0. 1 minus 1 is 0. 2 minus 2 is 0. What do you observe? The target was not to make this one 0, but it was to make this one 0. But in the process, this one automatically became 0. So you can see that one of the rows now is exactly 0. That tells us that the rank is 2. Two other rows are non-zero. This row, all the elements are not 0. All of them here are not 0. But this one, all the elements are 0. So we exclude that one. We now have 2 rows that are left whose entries are not all 0. That means that the rank of this matrix K is equal to 2. You get the point now? So the maximum number of non-zero rows is actually the rank of the matrix, having performed some elementary row transformation on that particular matrix. Now let's consider some matrices that are not square matrices. By square matrix, I mean that the matrix has equal number of rows and columns. That means the number of rows is equal to the number of columns. That's what a square matrix is. But there are some matrices that are not square matrices, and we can also determine the rank of that matrix. For example, let's take the matrix M that has the entries 1, 2, 3, 4, 2, 4, 6, 8, 3, 6, 9, 12. What is the rank of this matrix? We are to determine the maximum number of non-zero rows. Let's apply some row transformation and see. Okay, this is 1, 2, 3, 4, 2, 4, 6, 8. All right, 3, 6, 9, 12. All right, let's make this first element 0. In the process of time, we are going to see that some rows will be 0. If we make this one 0 by saying, let's say 2 times 1, 2, 2 minus 2, 0. I'll plug in the 0 here. I did 2 times 1, 2. 2 minus 2, 0. 2 times 2, 4. 4 minus 4, 0. 2 times 3 is 6. 6 minus 6, 0. 2 times 4, 8. 8 minus 8 is 0. All other entries remain. 1, 2, 3, 4, 3, 6, 9, 12. Let's make this one 0. We can work with row 1 now. If I multiply this one by 3, subtract it from this, see what will happen. 3 times 1 is 3. 3 minus 3 is 0. 3 times 2 is 6. 6 minus 6 is 0. 3 times 3 is 9. 9 minus 9 is 0. 3 times 4 is 12. 12 minus 12 is 0. All other entries remain. What do you observe? Two rows are entirely 0. That is, all the elements in the rows are 0. Row 2 and row 3. Only one row is having non-zero entries. It means that the rank of this matrix M is equal to 1 because we have only one row, which is row 1, that has non-zero elements, all true. Take the last example, number 6. Let's determine for the last example now the rank of this matrix A. Alright, see what I want to do. Let me make it easy for myself. I can swap rows here. See, this row 1, this row 2, this row 3. I can write this matrix as 1, 2, 3 minus 4, 1, 9, 16 minus 13, minus 2, 3, 7 minus 1. What did I do? I swapped row 2 and row 3. Why did I swap row 2 and 3? I observed that the first entry here is 1, here is also 1. I can easily make this entry here to be 0 if I place this row 1 in row 2. So if I just say row 1, row 2 minus row 1, 1 minus 1, 0, I'll get it. See, 1 minus 1, 0. 9 minus 2, what was it? 7. 16 minus 3, what was it? 13. Minus 13 minus 4. That's simply minus 13 plus 4. That will give me minus 13 plus 4 is minus 9. Yes, minus 9. All other entries remain. 1, 2, 3, minus 4, minus 2, 3, 7, minus 1. You get it? So we can now make this one to be 0. Okay, see, if I multiply this by 2 and I say 2, or I just say minus 2 plus 2, that will be 0 here. So times this by 2, minus 2 plus 2 is 0. Times this by 2, that will be 4. 3 plus 4, 7. If I times this by 2, that will be 6. 7 plus 6 is 13. Alright. If I times this by 2, that will be minus 8. So minus 1 plus minus 8, that's minus 9. All the entries remain 0, 7, 13, minus 9, 1, 2, 3, minus 4. Good. What can you see? Two rows are exactly the same. Making this entry here to be 0, for example, I will have to subtract either this from this or this from this. Whichever one that I subtract from the other, everything here, for example, will be 0. Okay, this will still remain. So what do you observe? One of the rows, all true, is 0. Only two rows are non-zero. That tells us that the rank of the matrix, which is the maximum number of rows that are non-zero, is equal to 2 for this particular matrix. This is how to determine the rank of a matrix by elementary row operations. Keep supporting, like this video, and share the video with your friends and your classmates. I'll see you in the next one.